equation z cubed minus az squared plus 2az minus 4i is equals to 0, where a is a constant as a root I. So I explain, okay, first one, why is I asterisk may not be a root of the equation. Number one, you know that by the complex conjugate root theorem, for the conjugate I to be a root, that's only provided if all the coefficients are real. So the coefficient has to be real. So in this case, it may not be true, because why? Because I star is the root, the coefficient of the polynomial must be real, right? So that's all for 7 part 1. Part 2, right, I want to show that a is equals to 2 plus I. Very quickly, I can sub w equals to I. So I do is I sub w equals to I into z cubed minus az squared plus 2az minus 4i, right, equals to 0. And I can see that, if I sub sub z as I will get I cubed minus ai squared plus 2ai minus 4i equals to 0. And this implies that I have a, eventually solving this, a plus 2i equals to 5i, and a is equals to 2 plus I. Alright, so next up, how about 7 part 3? How do I find the remaining roots of the equation in exact form? Okay, so what I can do is, I know that z minus I is a root. Right, that's one thing I'm sure of. I can say that this equation, if I'm going to say that z minus I equals, that means I can express it as a factor of the equation. I can write it in this way. Is z minus I, then probably maybe bz squared plus cz plus d, just to name some random coefficient, right? And it also is equal to 0. So with that, right, I can compare. So maybe if I compare the coefficient of z cubed, you can see that if I compare the coefficient of z cubed, you can see that b equals to 1. Alright, if you want to compare the coefficient of the constant, alright, you can also see that here negative id is equals to negative 4i. So actually d is equals to 4. So this is to compare the coefficient of a constant. Okay, after that, last one but not least, I need to compare, I need to find what is c. Right, so maybe what I can do is I can compare the coefficient of z. Okay, so first one, I see that the terms that give me z are as follows. One is this negative IC. Second one I can say is probably this one, which is ZD. So it's just like plus D. Right? On my left hand side, the coefficient of Z is just 2A. Okay? Okay, so from part 2 we know that 2A is just 2 plus I. Correct? 4 plus 2I. Okay, and we are done. So that's we have found C, we have found D, we have found B. Okay, so very quickly we can say that our equation can be written in the form of z minus I, okay, and bz squared. So it's z squared minus 2z plus 4, right, to be equals to 0. And solving this portion, right, you can actually use a calculator, or you can use the quadratic formula if you want to find the exact roots. So we can't use a calculator. It's 2 plus minus and you get your final answer here. And this one will be z equals to I. Okay, total of 3 roots.